We talked about isosceles triangles and we talked about equilateral triangles, right? So those two were the only two types of triangles that we talked about. Now, who can tell me what they know about isosceles triangles? What do you know about? Alarabi, what do you know? They have two equal sides. Good. And so if you know they're isosceles, they'll have two tick marks and only two tick marks. What else do you know about isosceles triangles? Two sides are the same and what equals 180? All the angles equal 180. Good. What else do you know?
The two base angles are equal.
Good, Mateo. The two base angles are equal. So you should have two sides that are the same, two angles that are the same. And then you've got one side and one angle that's different than the other two. Good. That's isosceles. What do you know about equilateral triangles? They have three equal sides. What else do they have? Three equal sides and three equal angles. Yeah. So all the angles equal 180 in total, right? Because it's still a triangle.
And you said about the angle of 60.
Yes, very good. So in an equilateral triangle, each angle has to be 60 degrees. And they're all going to be 60 degrees every single time. So if you see three tick marks, automatically that means all three angles are 60 degrees every single time. Okay. So on the back side, there are some practice problems. What I want to do with you guys on the back is I'm going to help you set up the equations, and then you guys are going to finish the equations on your own. Okay, so I'm going to help you identify what type of triangle each one is, and then I'm going to help you set up the equation. And you're going to take the rest of the class period then to finish the equations and solve. All right, but I'm just going to help you set each one up. So I'll start the problems with you. I won't finish them with you. Okay, so let's take a look on the back at the practice number 1. So I asked you to identify what type of triangle it was. And again, you only have two choices. It's either isosceles or equilateral. So if you take a look at number 1, what type of triangle is that picture? How do you know that, Rod? Good. Only two angles are marked as being the same. So automatically, since only two are given to me, it's isosceles. Good. Now, in an isosceles triangle, you have two angles that are the same and what else? Two sides are the same. So if you go to the angles that are marked, if you go directly across from them, you'll find the two sides that are congruent. Which two sides are congruent in this picture? So go directly across from the angles. Which two sides? Right, across from F is your first side, and then across from G is your second side. Those two sides are congruent or equal. They're exactly the same. If these two sides are exactly the same, what can I do with the two equations? Yeah, set them equal because they're exactly the same. So if this side, let's just say, was like 20 inches, well, then that means this side has to be 20 inches as well. They have to be exactly the same. So my equation, I'm going to take side GH, and I'm going to set it equal to side HF. And then I'm going to solve. So what is the length of side GH? What equation's given to you? X plus 47 equals, what's the other side? 7x plus 5. And then from here, it's just an algebra problem. So you're just going to solve it like a normal algebra problem. You're going to solve it for x. Again, I'm not going to do that with you. You can do that algebra on your own. So at the end, you'll get x is equal to some number. And then what will you have to do with that x value? Plug it in. Excuse me. Because the question asks me to find the length of HG. So once you get your x value, you're going to have to plug it in to side HG. All right, there's your first one, isosceles triangle. So again, I'm not going to finish it. You're going to finish it on your own. So we're going to slide over to number 2. All right, number 2. What kind of triangle is this picture? Is it isosceles or is it equilateral? How do you know? Good, 2 sides are the same. So I'm going to put, if you don't mind, I'm not going to write the whole word out. But it's isosceles because you've got 2 sides that are exactly the same. Fantastic. Well, if you have 2 sides that are the same, what else is the same? Which 2 angles are exactly the same? Do we agree with Cameron? Are C and D the same?
Yes.
Yeah, good. They're right across from the tick marks. So angle C and angle D should be exactly the same. Well, if they're the same, what does angle D have to be? Yeah, it has to be the exact same thing, excuse me, 3x plus 8. I have to have that over here as well. Right, because they're exactly the same. All right, so if I have 3 angles given to me, beautiful, I can add all 3 angles together and set them equal to 180 because every triangle equals 180 on the inside. So I'm going to add angle B plus angle D plus angle C, and I'm going to set the whole thing equal to 180. And then you're going to solve it like an algebra problem. So you have to add all 3 angles together. Do I have to write that out or is that okay? Do you know what to do from there? Okay, so you're just adding all 3 together and solving for x. It just becomes an algebra problem, which I know you can do. All right, questions on that one? Can I go on to the next one? Yeah, all right. I'm just taking the no response as a yes. Okay. Number 3, what kind of triangle is it? Isosceles or equilateral? Why? Yep, 2 base angles that are the same. Fantastic. These 2 angles are the same. So this is isosceles. All right, in an isosceles triangle, you have 2 angles that are the same and 2 sides that are the same. Which 2 sides, be very careful, are the same?
JL and KL.
JL and KL. Very good. So the 2 sides across from the angles. All right. So if those 2 sides are exactly the same, what can I do with those equations?
Equal.
I can, set them equal to each other. So I'm going to take side JL and set it equal to side KL. And then I'm going to solve it like an algebra problem. So side JL is 4x minus 12. And what's side KL? 20. So if this side is 20, what should this side be?
20.
It should also be 20. They should be exactly the same. So you're going to solve for x, and then it asks you to find the length, so you're going to have to plug it in everywhere you see an x. All right, so you'll solve for x, and then you're going to have to plug it in. Again, I'm not going to finish it because it's algebra, and you can finish the algebra. Questions there? Are we cool to go on to the next one?
Yeah.
Yes. Okay, fantastic. All right, number 4. Is this isosceles or equilateral? Ooh, why? Yep, it's got a tick mark on all 3 sides. So this one is different. This one is equilateral. Okay. So in an equilateral triangle, all 3 sides are the same. What else is the same? All of the angles are exactly the same. So if this angle P is 1/2 x minus 10, what does that mean angle Q is? And what does that mean angle R is? Okay, so you've got 3 angles. Now, how can I set up this equation?
1/2 x minus 10 equals 60.
Ooh, good job, Mateo. Yes, so in an equilateral triangle, each angle, I think Larrabee told us this at the beginning of class, is 60 degrees, right? So this is 60 degrees, this is 60 degrees, and this one's 60 degrees. So because they're all 60 degrees, I can just take this equation right here and set it equal to 60. And then I can solve that way. That is one way you can do it. What's another way you could do this problem? That's a great way to do it. What's another way you could do it? What do all the angles in a triangle always add up to be? 180. So if you wanted to, you could do 1/2 x minus 10 plus 1/2 x minus 10 plus 1/2 x minus 10 and set it equal to 180. It will still give you the same answer, just need a little bit more work. Okay, but either one's going to give you the same answer. Now, last thing, and then I'll go on to the next one. If you don't like the fraction, if you're not a fraction person, you prefer a decimal, how else could I rewrite 1/2? Yeah, so if you want to put it as 0.5x minus 10, that's fine too. However you want to solve it, because I know some people are not fans of fractions. So if you want to do it as a decimal, you'll still get the same answer. All right, again, I'm not going to finish it because it's algebra, and you're going to finish it on your own. So let's go to the next one. Questions there? Feeling good? Okay, great. Let's go. Number 5 and 6. So these two go together. What type of triangle is number 6 or 5 and 6? Was it isosceles or equilateral?
Equilateral.
Why?
That's pretty big.
All right, equilateral. So notice that the first thing I always do is decide what type of triangle it is, because that's going to help me set up my equation. Now, this one's a little different because I have 2 variables this time. I know in an equilateral triangle, all 3 sides are the same, and what else?
All 3 angles are the same.
All 3 angles are the same. So angle S, angle T, angle U are all exactly the same. Now, that would be great if I had 2 of the same variable, but I've got one with a y and one with an x. What do you think I should do?
Could you set one equation to 60? And then
Beautiful.
solve for that?
Yes,
and
you
then plug
could.
it in?
It's exactly what you can do. So each angle has to be 60 degrees. Angle T is 60 degrees. Angle S is 60 degrees. Angle U is 60 degrees. So what I can do is, instead of trying to add them all together because I have an x and a y, I can set each individual equation equal to 60, and then I can solve it. So if I do my y's, how would I set up that equation?
25 minus 15 equals 60.
Perfect. I can do 25y minus 15 equals 60. How would I set up my equation for the x?
20x equals 60.
Yeah, 20x equals 60. And then I go through and I solve them both. Not too bad, right? So I kind of like, equilaterals more because if you just set them equal to 60, it makes your life way easier. If you wanted to technically add them all together and put them equal to 180, you could. It just would be more work for you. All right, let's push ourselves over to the next one. Now I'm gonna do part of this one with you because this one's a little different. Why is this one a little different?
There's 2 triangles.
This time I got 2 triangles. Okay, so I'm gonna go in order of the variables it asks me to solve for. Excuse me, because if we go in order, it's gonna help you out. I asked you to do that order for a reason. So the first one we're going to solve for is W. So W's down here, and it's within this bottom triangle. So I'm just gonna look at this bottom triangle, and I'm just gonna ignore this triangle for now. Okay, I'm just gonna look at that one right there. Now, if you're looking at that bottom triangle, what type of triangle is that bottom one? Ooh, which one is it? Why? There's only 2 tick marks on the bottom one, just the bottom one. There's 2 tick marks. That means it's an isosceles triangle. Okay, so if it's isosceles, it's got 2 angles that are the same and 2 sides that are the same. Which 2 angles are the same?
The sides.
Which sides? So I've got a 64 up here. I've got a W down here. What should this angle right here be? It should be the same as the other base angle. So since this angle is W, that means this angle is W. They're both W. Okay, now you've got all 3 angles in that triangle. How can I solve for the variable? What would I have to do?
W plus W plus 64 equals 180.
Yeah, good. So a couple of you are starting to say that too. I'm going to add all 3 of them together and set it equal to 180. So I'm going to add W plus 64, set it equal to 180. Okay, and then it becomes an algebra problem. So what can I do first?
Combine like terms.
Combine like terms. So I can put together W and W. What is W and W? 2 W's, yep. All right, what do I do next? Subtract the 64. I get 2W equals 116. And what's my last step? Divide by 2. What do I get for W? 58 what? Degrees. Yep. Okay. So I've solved my first angle. This angle right here has to be 58. This angle over here has to be 58. Okay, fantastic. You got the first one. Now, second one it asks me for is angle X. Here is angle X. All right. Any ideas what we can do to find angle X? Where is angle X located? Next to the W, and the W is 58. Well, ooh, so close. I would like that if it was the whole triangle, but I've got another piece over here, don't I?
What do you mean 58? Can you like subtract it for like 90 or something?
So it's not vertical. Vertical means it makes an X.
Oh.
Why would I subtract it from 90?
It's like the right angle.
Ah, there we go. There's a right angle right here. So I already have 58 of the 90. So to figure out what's left over, I'm just going to subtract the 2. 90 minus 58. And what do you get when you do that? 32 what? Degrees. Very nice. So now you figured out angle over here is 32. Okay, what's going to be my last one now to try to solve for y? Okay, well, I like where you're headed, Sierra, but if you wanted to add everything up to set it equal to 180, I would need to know this angle over here to do that. I don't have that one yet. I could figure it out, though. How could I figure out this angle right here? Ah, why would you do 180 minus 64? Ah, this is a straight line right here. Ooh, okay. So it's a linear pair. Remember that from last chapter, 2 chapters ago?
Yeah.
So I can figure out this angle right here by doing 180 minus 64. What is 180 minus 64?
116.
116. Okay, so now I've got the 32, I've got the 116, and I've got 2y. So what can I do from here? Add them all together and set them equal to 180. Very nice. So I can add 32 plus 116 plus 2y and set it equal to 180. And then it just becomes some algebra. So what can I do first? Combine like terms, and what are you going to combine? Good. What do you get when you add those together? 148, right? Okay, now what do I do? Subtract 148 from both sides. I'm running out of room. That's okay, because we're not even going to do 14 and 15 anyway. Nope. 2y equals 32. Oh my gosh, look at that. 2y equals 32. These two were the same anyway. It was an isosceles triangle. Woo! Yeah. Okay, and then what's the last step? Divide by 2 on both sides. What do you get? What? Over half. Y equals 16. Woo, that was a lot of work. Okay. So those ones were a little tougher because they were like right next to each other, right on top of each other. But if you determine what kind of triangle it is first, and then you try to set up the equation, it's going to make your life way, 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 way easier. Okay. All right. So we've got 15 minutes left. You are going to finish up to number 6. You do not have to do 14 and 15. Okay. So I want you to definitely finish till 6, and then I do want you to attempt that last problem over there, 10 to 13. Give that one a try, but we'll go over it, I think, by the end of the class period, okay? If you're done, that's fantastic. Then you can chill out for a little bit. But we got about 15 minutes, so I'd like you to finish up the rest of those algebra problems that we set up, and then we will go from there. Okay, so I'm going to give you a little bit of time right now to finish those up.